Alright, so far we've talked about two different types of segments within triangles. We've talked about mid-segments that go from midpoint to midpoint. We've talked about perpendicular bisectors that'll bisect a side of a triangle at a right angle. And then today we're going to be talking about angle bisectors of triangles, which, if you remember, an angle bisector is anything, usually a ray, that's going to cut an angle and make two congruent angles. So an angle bisector is a ray that divides an angle into two blank adjacent angles. Well, like I just said, that would be two congruent adjacent angles. So just a refresher on what an angle bisector is. So we have an angle bisector theorem, which says if a point is on a bisector of an angle. So here D is on our angle bisector. If that's the case, then it is equidistant, so equal distant from the two sides of the angle, or the two rays that make up that angle. Now when you talk about distance from a point to a line, we talked about this earlier, that distance always needs to be perpendicular to that line we're talking about here. So you have to have these right angles here in order to represent that distance. So because D is on the angle bisector, these two segments, BD and DC, are going to be equal. They're going to have equal length. So the converse is also true. If you have a point, okay, say D, if it's on the inside of an angle, and it's equidistant to the two sides, so here we know it's equidistant, and it's not just because of these congruent marks, we also need these right angles as well. So because we have that, it's equidistant to those two sides, that means it's on the angle bisector. Okay, so in other words, these two angles would then have to be congruent. So, it says find the measure of angle BAD. So here on number 1, angle BAD is right here. We want to find that measure. Well, since D is equidistant to the two sides, that means this is an angle bisector, which means if this is 36, then the measure of angle BAD is also going to be 36 degrees. Number 2, so here the whole angle is 84, and usually someone's going to say, oh, that's going to be 42 degrees because it's on the angle bisector. Unfortunately, we don't know that. Now, it is a distance of 2 here and a 2 here, so these two are equal, but because we don't have a right angle in this position, we don't know that D is on the angle bisector. So to find that angle, we can't do it. So that would be unknown, or can't be found, because we're missing that right angle. So you got to have that. 3 says solve for x. Well, if you notice here, we are on this angle bisector. These are perpendicular. So therefore, these two segments are going to have equal length. So we can say 5x minus 22 equals 2x minus 7. Subtract the 2x and add the 22. And x would be 5. So again, a couple things you got to look out for. You got to have those 90-degree angles in order to figure out a lot of these problems out. Because as we said, if you find a distance from a point to a line, that distance always needs to be perpendicular. So here it says, can you conclude that segment BD bisects ABC? Well, if you've been paying any attention at all during the video, your answer should be no. And again, the reason is we do not have right angles here or here. So if you've taken away anything so far, is that in order to know that this point's on the angle bisector, you either need to know that it's an angle bisector, or you have to have congruent segments with 90-degree angles. You need to have both things. Find the missing coordinates, then calculate the length of AC and find the midpoints of segment AB. Okay, let's start with the missing coordinates. Point A, well, if we look at point A, it is on the y-axis. So that means it does have an x value of 0. And this tells you have a height of h, so the y value is going to be h. Down here, well, our x value, since we went 2h that way, is 2h. We're on the x-axis, so we didn't go up at all, that's 0. And this is straight right of A. It's straight above C. Obviously, there's no zeros, but we know it's above the 2h, so 2h. And then the y value is going to be h. So those are those coordinates. It says calculate AC, so we got to find the distance from here to here. So AC, if we use distance formula, which again, subtract your x's and square them, plus subtract your y's and square them. So A and C, our x's are 0 and 2h. So 0 minus 2h, I'll write the whole thing out this time. And then we'll have h minus 0. That whole square root. Well, 0 minus 2h, that's negative 2h squared. H minus 0 is h. If we square this, well, negative 2 squared is 4. H squared, we know is h squared. And add those two up, we get square root of 5, h squared. So that would be your length of AC. And then find the midpoint of AB. So again, midpoint, you add your x's up and divide by 2. So 0 plus 2h is 2h. 2h divided by 2 is h. Then we look at our y's. H plus h is also 2h. And again, 2h divided by 2 is h. So our midpoint of AB is going to be h. One other theorem today. So just like yesterday we talked about where all those perpendicular bisectors intersect, now we're talking about where all your angle bisectors intersect. Does the angle bisectors of a triangle intersect at a point that is equidistant from the sides? So perpendicular bisectors are equidistant from the vertices. Angle bisectors are equidistant from the sides. So the angle bisectors are the blue ones, so that point is equidistant to all the sides. That point is called your incenter. The other day we learned about the circumcenter, which is where the perpendicular bisectors intersect. There's a lot of vocab here. All right. So, as we said again, these lengths would all be equal if the angle bisectors meet up at that point. So, it says G is the incenter of the triangle. So let's stop right there. If it's the incenter, that means it's where all of our angle bisectors meet, which means it's equidistant to each side. So now we're supposed to find the value of x. Well, the only values I really know is that all three of these are 2x. We're supposed to find GD. Well, so if we can find x, plug it in, find this, we'll have GD. So let's find this. We're going to use Pythagorean theorem. Now, if you think you're really good at Pythagorean theorem, that's great. Don't zone out because you're probably going to mess this up. No offense. So, Pythagorean theorem, a squared plus b squared equals c squared, right? Now, if you do this, you're wrong. The problem with this is, right now, the x is the only thing getting squared here. So what you want to make sure is you put parentheses around what's being squared there, the 2x. Because actually when you square that, you're going to end up with 4x squared. The 2 gets squared as well. So 16 squared, if I remember right, is going to be 256. And 20 squared is 400. Then we would subtract. Then we're going to divide by 4. And let's see, that's going to be 38, doesn't it? Actually, that seems wrong too. 36, that's what it is. And then you square root, and x would be 6, which also means GD itself, right here, is also 6. So again, the main concept of today, we're talking about angle bisectors. So you show what an angle bisector is already. What we added to that is an angle bisector is equidistant to the two sides that make that angle. Okay, this angle bisector is equidistant to those two sides. In order to know that, again, you got to have those right angles. Okay, in center is where they meet, and kind of like that first theorem, when you have that in center, that's going to be equidistant to all your sides because it's where your angle bisectors meet. They all these theorems kind of work together as one. And that would be the assignment.